Let's move on to another example in which we model a real-world situation with a basic system of linear equations. Our second scenario is the following. The movie theater ran 2 special showings of Tack Attacks. The 10 a.m. showing sold 62 children's tickets and 21 adult tickets for a total of $291. The 2 p.m. showing sold 29 children's tickets and 36 adult tickets for a total of $267. In the end, our ultimate goal will be to find out what the price of both the children's ticket and the adult's ticket is. So let's start with our variables. C can represent the price in dollars for a children's ticket. And A can represent the price in dollars for an adult ticket. We'll need 2 equations, and I think the most appropriate would be to have one for each showing. So we'll have an AM equation where we know that 62 children's tickets, so it will be 62 times C, and that will represent the number of dollars earned, I guess you could say earned, brought in by children's tickets, which will then be added to 21A. That'll be the dollars earned by adult tickets, which will then equal $291, which is the dollars earned for all tickets. And the key is that we have dollars plus dollars equaling dollars, so our units are consistent. Our PM equation will just use different coefficients, but the idea is still the same. Dollars plus dollars equals dollars. So 29C plus 36A will equal 267. Now, what I would like to be able to do is identify these functions as the graphs. And what I think I'm going to do is, since I do have a standard form here, it would make the most sense to go ahead and maybe find the x and y intercepts, or in this case, the children or C intercepts and the adult A intercepts. And so I'll use a classic little trick. I'll use this up here, where we'll go to find the C and the A intercepts for the AM equation. We can go 62C plus 21A equal to 291. Realize that if we're going to do the C-intercept, that's because A is equal to 0. And so we can essentially cross out that and then solve for C. And if we divide both sides by 62, with a little typing on the calculator, we came up with a C value that is approximately 4.69. We'll just say 4.7, which means that it would have the point 4.7 comma 0 if we put the C on the x-axis. Let's do this again for the A intercept, where we go 62C plus 21A equals 291, except this time we'll cross out the 62C because C would be equal to 0, and that would just be 0. And when we divide both sides by 21, we'll come up with an A intercept that worked out to be 13.85, and if you round it, it'll be about 13.9. And if the A is actually the y-axis, then we'll look for a point that's 0.139. And so let's move to the bottom of this particular paper, and we'll see that there it is, children being the x-axis. This is roughly about 4.7, comma 0. This is definitely looking like 13.9 as an a-intercept. So this must have been the AM equation, and this one would be the PM equation. Now, of course, this is the graph that I already produced. We should probably produce it, and we will need to produce it in GeoGebra. So let's go into GeoGebra, and let's type in our first equation. Now, you can type in the equation as a standard form, so if you decide you want to go 62, just remember you can't actually use C and A for your variables for graphing. You can go 62x plus 21y equals to 291. And in this particular case, you'll see that it's listed as EQ1, okay? And I do see the x-intercept roughly crossing at 4.7, but I don't see the y-intercept. Well, what we'll do is we'll come to this last icon in the menu bar up here, and it's called Move Graphics View. And if you just click here and drag it, you should have enough information to be able to see your graph. Let's make the font size a little larger, so we'll go to Settings. We'll choose the font size to, let's say, be 24. It's a little easier to see. We don't need to have all that room, so we'll slide that back. And what I'm going to need for the project is I'm going to need to be able to see both my X and Y intercepts, or in this case, the children's and the adults intercepts. And I can see that one here, and I can see that one here. I don't need to actually have them labeled as points. I just need to be able to see that they did cross the axes. Speaking of the axes, we should need to also label the axes. You have a couple of options, okay? You could actually label this axis through its settings. Like if I click here, and you'll see that if I click in an empty space, you'll go back to your settings, and there will be an x-axis, and you can actually go over here and you could actually type in the label and say, C equals children's ticket price. And that will put it in that nice little spot. The problem is, I really can't move it from that location, all right? It's kind of stuck to the axes. So I actually kind of prefer the following. Let me erase this. And to give me a little bit more flexibility, I'm going to go to the second to last icon, second to the right, and under here you'll find text. If you click on ABC, and then click over here in the empty space, you can actually choose to enter your own text. C equals children's price, okay, children's ticket price. I might even want to include the fact that this is dollars, because I should remember that. I can go ahead and hit OK. I can then move it, unlike before. I'll, of course, have to click on the move icon so I can pick it up and then literally move it. But I can also have a little bit more control. Once it's kind of selected, you'll see that in my settings, I can actually choose text. I can make it bold. I could make it a little larger. I could make it like a medium size. I can then relocate it. It just gives me a little bit more options on doing so. In fact, you know what I'm going to do? I'm going to put that underneath here. Okay? Let's do this again with the adult ticket price. We'll come over here. Click on the empty space. Inside the text, I'll type in A equals adult ticket price. We'll throw on a little $sign there. I think I want it to be bold. I think I want all the rest of those to be off. I'll hit OK. Let's move this over here a little bit, and we can slide this over here a little bit. I think that looks pretty good. We'll just click on this so that I can pull up the options. And we can make this just a little larger with the medium size. Let's go in and put in the second equation. However, before I do that, you'll notice that this says EQ1, and it doesn't really tell me that's AM. I don't know that the first one is the AM or PM, and I kind of want to know that. You can actually come over into its settings. Like if you click here and you click on it, you'll see that you get the settings options. You can actually go over here to where it says name, and you could type in pretty much whatever name you want. I think I'll stick with the EQ, but I'll say AM. I can actually choose the color of this one. The one on my graph was blue. I'll kind of keep it that way. I can even change the style. I have a couple different options. I can go with this light dotted line, and I can even make it thicker and easier to see. Yeah, that looks pretty good. So now when I do the second equation, Let's actually type in EQPM right away, and we can go ahead and type in 29x plus 36y equals 267. You'll see the graph. We hit enter. It labels it as EQPM. We can move that out. We can have that highlighted. Click on that. That should give us the options where I can go to color, change that to red, click on style, and we'll change it to a slightly different dotted line and increase its thickness as well. You know what, now that I have that red line there, let's pick up the children's ticket price. You know what, let's put it up here after all. I like that. I see my two C-intercepts here and here, and I see my two A-intercepts here and here. Functions are labeled. So now let's return back to our work on scenario number 2. You'll see that I have reproduced the graph on the bottom right using GeoGebra. I went ahead and labeled both the axes as well as equation labels for both on the bottom part of this paper as well as GeoGebra's project. And so now let's go do some of the cleanup work where identifying the independent and dependent variables includes the following. The x-axis, which is where you'll find the independent variable. Was going to be essentially C. And that is, again, the price in dollars of a children's ticket. And the y-axis is the dependent variable, which in this case is A, the price in dollars of an adult ticket. So let's begin solving for the prices of each ticket by using 3 different methods. The first method we'll use is the elimination method. And that is where we're going to have, let's say, our 2 equations, 62C plus 21A equal to 291. And we're going to have 29C plus 36A equal to 267. And what we want to do is, in this case, let's eliminate the A from the picture. And to do that, what we will want to do is, let's take the coefficient of 36 and use that to multiply the top equation by, and we'll distribute, and we'll come up with 2,232C plus 756A equal to 10,476. We'll take the coefficient of the A in the first equation, we'll multiply it to the second equation, but the problem is 21 times the positive is still positive, and that doesn't cancel at the 756, so we'll throw a negative in there, and that will recreate the equation as negative 609C minus or plus a negative 756A equal to negative 5,607, which, when added together, as I stated, the whole goal was to eliminate the A's, gives us 1,623C equal to 4,869. And if we go ahead and solve for 1623C equals 4,869 and divide both sides by 1623, you will find out that your children's ticket is $3. So we could take that value of C equals 3. We could substitute it into any of these equations. You could put in that one. Technically, you could even put in these two and use that to solve for A. But if you are working on this project with a partner, you need to demonstrate elimination. So you will essentially eliminate A to solve for C. Your partner would need to eliminate C to solve for A. So since we are trying to demonstrate the elimination method, what we'll do is we'll eliminate C as well. And so let's do this all over again. 62C plus 21A equals to 291. 29C plus 36A equals 267. Except this time, we'll use the 29, the coefficient of the second C. We'll multiply that to the top equation. And that will produce 1798C plus 609A to equal 8,439. We'll take the coefficient of 62 in the first equation, C. We'll put that on the bottom. Realize that that's already positive. We'll want this to be negative, so we'll use a negative 62, and that will come up with negative 1798C. Now we'll come up with a positive negative 2,200. Oops, that didn't look very clear there, so let's put that negative a little bit more distinct. Negative 2,232A equal to negative 16,554. And since these will cancel out, just that was our goal, to eliminate C, we will come up with negative 1,623A to equal negative 8,115. And that's what we're about to get. We're going to get negative 1623A equal to negative 8,115. And we'll divide both sides by negative 1623 to find out that our adult tickets were going for $5.